A very good evening to Madam. My name is Nur Akila binti Ilyas and I'm from CE1 Group 40. My group consists of me and also Amir. So today we are going to present you the project entitled Methanol Production Using Steam Reforming Process. So this presentation will cover Chapter 1, Introduction, Chapter 2, Process Flow Diagram, and also Chapter 3, Chemical Engineering Thermodynamics. So now let us move on to Chapter 1, Introduction. So methanol is commonly being used in vehicle fuel blending, such as gasoline, to produce a high octane gasoline so that it has a better quality, and also marine fuel to being blended with gasoline as well in order to produce excellent quality fuel known as methyl tertiary butyl ether. And also methanol is being used as the feedstock to produce another chemical such as formaldehyde and also acetic acid, and it is being used as antifreeze as well in windshield of washer fluid. So it is being used as industrial solvent to produce resins, inks, and also dyes. And most importantly, methanol is flammable, volatile, and fatal for consumptions. And it consists of chemical properties which can lower the freezing point and increase its boiling point, and that's why it is being used as an antifreeze. So methanol also is being injected in the natural gas pipelines to lower its freezing point of liquid during oil and gas transport for safety purpose. So for plant capacity, there are two types of plant capacity for methanol production, which are small and big scales. So for small plant scales of methanol has the capacity of approximately 15,000 tons per year to 20,000 tons per year. Meanwhile, for big plant scales has the capacity of approximately around 1 million to 2 million metric tons per year. So for market analysis of methanol, so based on these two references, which are Methanolog and also Methanex, United States and also North America has the highest market price due to rising in demand but tightly supplied. So probably another reason is due to the pandemic that occurred this year. So for demand trend of the globally methanol market, it is expected or being forecast that it will be increased steadily until year 2025 despite of the pandemic issues, according to expert market research. So for global market usage, methanol is majorly or commonly being used as the chemical feedstock to produce formaldehyde, and secondly, it is majorly being applied as fuel application to produce a better quality of fuel vehicles. And for global market of methanol, based on expert market research, it stated that China is the largest market of demand of methanol, United States is the largest importer, and Saudi Arabia is the hugest exporter of methanol. So for selection of instrument for methanol production consists of compressor, cooler, mixer, heater, steam reforming reactor, methanol synthesis reactor, condenser, splitter, recycle operator, syngas recovery unit, methanol purification unit, and also reboiler. So now let us move on to chapter 2, which is process flow diagram. So For stream 1 and stream 2, which consists of methane and steam, will pass through the heater and also mixer and being fed into a steam reformer. And in this steam reformer, there are several reactions that occur. So this steam reformer is being used to convert methane and steam into synthesis gas. So the reaction that occurs are, firstly, the methane is reacting with the steam to produce carbon monoxide and also hydrogen. And second reaction is carbon monoxide react with the water to produce carbon dioxide and also hydrogen. So then the components in steam 3 is being fed into the condenser, and this condenser is used to remove the excess water, and the remaining components are being fed into the compressor and also methanol synthesis reactor. So for methanol synthesis reactor, the reactor chosen is the equilibrium reactor. So the components in the stream 6 will pass through or be fed into the syngas recovery unit, which is the distillation column, and as represented by stream 6, and in stream 7, which is mainly the components are carbon monoxide and as well as hydrogen, is being recycled back and into the splitter, and 10% of components in stream 7 will go to purge, and the remaining 90% will be recycled back as represented in stream 8 into the methanol synthesis reactor. So for stream 10, which is the methanol that being fed into methanol purification units, in order to further purify so that 95% grade of methanol can be obtained. So the water produced from the methanol purification unit will be sent into wastewater treatment plant. So that's all from me. Now I'll pass to Amir to further explain for chapter 3. Thank you so much.